Welcome to qnawire.
Let's find the absolute minimum and absolute maximum values of the function f of x equal x minus 2 inverse of the tangent function on x defined on the closed interval 0, 4. So first we note that this function is continuous over the interval 0, 4, and that's because the function inverse of the tangent is defined on the real numbers and is continued on the real numbers, so it's particularly defined and continuous on the interval 0, 4. Remember that if we constrain the tangent function to the domain negative pi half open interval both sides, then we have the inverse well defined, which is the function that we call tangent to the negative 1 of x, which is the inverse of the tangent function, which is then like this. So as we can see, this function is defined and continuous on the real numbers. Well, so let's say here this is tangent to negative 1 of x. So f being continuous and defined on a closed interval, it attains its extreme values on that interval, and we know that those extreme values get to be attained either on the endpoints of the interval or at critical numbers of the function f. So we get to start by calculating the first derivative of f, which is 1 minus 2 times the derivative of the inverse of the tangent function of x is 1 over 1 plus x squared. So this is equal to 1 minus 2 over 1 plus x squared, and that's equal to 1 plus x squared as a common denominator. In the numerator we have 1 plus x squared minus 2. So the first derivative of f is equal to x squared minus 1 over x squared plus 1. And the denominator we have in this expression is never 0. In fact, it's always positive, x squared plus 1. And so we have that this derivative exists for every x in the closed interval 0, 4. For that reason, we can say that the only critical numbers of f in the interval 0, 4 are those values of x in that interval for which the first derivative is equal to 0. And so we get to solve this equation here, and we start with that equation. And because we know this first derivative is equal to this expression here, this is equivalent to saying that x squared minus 1 over x squared plus 1 is equal to 0. And this is the same as x squared plus 1, x squared minus 1 equals 0. That is x squared equal 1. And from here we know that x can be negative 1 or x can be 1. But in this case, the value negative 1 is not in the interval 0, 4. Then we can say that the only critical number of the function f in the interval 0, 4 is x equal 1. So we have this critical number and the endpoints of the intervals as candidates for the function attain its extreme values. So we can say that f at the left endpoint 0 is 0 minus 2 inverse of the tangent function at 0, and because the tangent of 0 is 0, we get that this is equal to 0. And at the writing point 4, the function is equal to 4 minus 2 inverse of the tangent at 4. And using a calculator, we found that this value is approximately equal to 1.3483646727. And finally, f at the critical number x equal 1 is 1 minus 2 inverse of the tangent at 1. And because we know the tangent of pi fourth is 1, this gives us 1 minus 2 times pi fourth, which is 1 minus pi half. And that's approximately equal to negative 0.570796 3268. Okay, so these are the candidates for string values of the function. So the largest of the three values is this one here. So it must be the absolute maximum value of the function over the interval 0, 4, and it is occurring at the writing point 4. So I will write this here, absolute maximum value of the function attained at the writing point 4. Now the smallest of the three values is this one here, 1 minus pi half, and that's attained at the critical number 1. So this must be the absolute minimum value of the function over the interval 0, 4. So we write the answer following this observation here. So the absolute minimum value of the function f in sorry on the interval 0, 4 is this one here, is 1 minus pi half, which is approximately equal to negative 0.570796 3268, and that absolute minimum occurs at 1, that is at the critical number. Now for the absolute maximum of the function on the interval 0, 4 is this one here, 4 minus 2 inverse of the tangent function at 4, which is approximately equal to 1.3483646727, and that absolute maximum value I forget here, value which occurs at the critical number x equal 1. And I think I wrote 1, which is 4. It's clear. Look at this. It's this value here. This value here is at so sorry. No, it's 1. It was okay. Let's stop a little bit here. Perfect here. The critical number is 1. We found it here above. Let's see it again. Critical number is 1. So at that value 1, we have the absolute minimum. So the absolute minimum is 1 minus pi half, which is approximately equal to this value, and that occurs at critical number 1. It was perfect. Now for the absolute maximum value is 4, this one here, 4 minus 2 inverse times that 4, which is approximately equal to that, and that occurs at is not the critical number. I'm repeating what it was above. It happens at 4, that is the right endpoint of the interval. So here, of course, at the right endpoint, x equals 4. Sorry for that. So this is the correct answer. And we recall a little bit what we have done here. So the first thing we get to do is to verify that the function is continuous on the closed interval. That tells us that the extreme values of that function exist on that interval and are attained either at the endpoints of the interval or at critical numbers of the function. We calculated the first derivative of the function. We saw that that exists for every argument x in the interval 0, 4, and for that reason the only critical numbers of the function in the interval 0, 4 are those values of x for which the first derivative is 0. We stated that equation, and there are two solutions, negative 1 and 1, but one of them, namely x equal negative 1, is not in the interval 0, 4, so the only critical number of the function f within the interval 0, 4 is x equal 1. So we have the critical number 1 and the endpoint 0, 4, so we evaluated at those 3 points, and with that we found that the absolute maximum value of the function over the interval 0, 4, which corresponds to the largest value calculated, largest of the 3 values calculated, is 4 minus 2 tangent inverse at 4, which is in fact the value that occurs at x equals 4. So the absolute maximum value of the function over the interval 0, 4 is 4 minus 2 inverse of tangent at 4, that which is approximately equal to 1.3483646727, and it occurs at the right endpoint of the interval, that is at 4. That's the largest value we found, and the smallest value, which is 1 minus pi half, which is approximately equal to negative 0.5707963268, is then the absolute minimum value of the function over the interval 0, 4, and it is attained or occurs at the critical number x equal 1. And so this is the final answer to the problem.